to kind of review the Pythagorean theorem. A lot of you probably did this in previous math classes. What is the formula for the Pythagorean theorem? Very good. A squared plus b squared plus c squared. Don't worry, that will be given to you. So you don't already have it memorized, you don't really necessarily need it. It's helpful. You get it on your formula sheet. Well, with a squared plus b squared plus c squared, or equals c squared, in your right triangle, the side across from the 90-degree angle, always your c. You go to your 90-degree angle, the one with the box, go straight across, that guy's your c. The other two do not matter. One could be A, one could be B, does not matter. You could have made 6B and 3A, does not matter. The one that does matter is the one across from your 90. It's always your C. And it's always your biggest side. Well, then you just take those values and plug it into your formula. So we said A was 6, B was 3. We didn't get a value for C, so we just leave it as C squared. Oh, what is 6 squared? What? What's 3 squared? And we don't know what C squared is. 36 plus 9 is what? 45. We want to get C by itself. How do we get rid of that square? The root it. The root both sides. So we get that the square root of 49. If you try to take the square root of 49 in your calculator, do you get a whole number? No, these are long ugly decimal, right? So you have to be really careful. Sometimes your directions are going to say round. Sometimes it's going to say even simplest radical form. Well, here we need to leave it in simplest radical form. Check to see if it's a perfect square. If not, you need to simplify it just like we did at the beginning of class. And make two new square roots and figure out what's the largest perfect square that can go into 45. Track 5. 9. How many times does 9 go into 45? 5 times. That first one has to be a perfect square. The second one just how many times the perfect square goes into that number. What's the square root of 9? 3. Can't take the square root of 5. Check it out. So you have to leave in simplest radical form. Your answer has to be a radical. And you have to simplify it if you can. This is round, and you can just plug your calculator in round.
Real quick too, those of you who like to borrow our calculators, because you have to use your calculator on the test. If you borrow our calculators, again, these are not the greatest calculators in the world. Again, we recommend get your own, Halloween coming up, all that good jazz. You have to work backwards on these calculators every time you use them. So if I want to check to see if that's a perfect square, if you don't know if 45 is a perfect square, I literally have to hit 45 first. Well, my calculator works. Okay, let's pretend that one works. I'm going to hit 45 first. There we go. 45, then I'm going to have to do the inverse and then do the square button to get my answer. Let's see. All right, you get 6.7, so you know that's not true. Okay, so that's what you have to do, break it down to simplest radical form. Great way to check yourself. But if you're using our calculators, try it out.
If we take a look at the next one, again, from side across from the 90s, always your C. This is A, this is B, doesn't matter. The one that matters is the one across from 90 is always your C every single time. And then you fill those values into the formula. What's it going to look like when we fill these values in? And then simplify. 4 squared? 8 squared? Well, C squared. 16 plus 64? Is it? Good. 80? And again, what do we have to do to get rid of that square? 16 good? How many times is 16 go into 80? 5. The square root of 16. Or, we take the square root of 5. Nope. Nope, we're done. Questions?
There may be somewhere deep in the archive, I know. All right. So find the missing side of the following right triangle. Good, it's a right triangle. Now we can round our answers to the nearest 10. So those of you with the borrowed calculators, you can still do it, so it's good. All right, well, let's go ahead and make sure we stay consistent. Let's label our sides. One thing I like to do is we know the C is always across from the right angle. So you're going to have it. When I think about this, I visualize it like this. This guy looks like an arrow. It's pointing at the C side. The hypotenuse will come into play later. So there's my C. It's always going to be the longest side. The A and B doesn't matter. I just call the littler side A. The smaller side I call A, the other one B. And let's go ahead and set up our formula now. So A squared, so it'll be 39.9 or 3.9 squared plus B squared is equal to, oh, it's not C, it's 11. 11 squared. Wouldn't be able to solve it if we had that. There's my setup with all the values that I have. Let's go ahead and start solving. Everyone should have a calculator tabulating this, getting that practice so you know how to do it. Come quiz and test time. 3.9 squared. Again, borrowed calculators is 3.9 squared, or everyone else just type 3.9 squared. How do we get? 15.2 what? See, there's nothing else? 2-1. Let's just say the whole thing right here, just for the sake. Because if it goes on forever, you can round, that's fine. But it stops right there. We're good. Plus B squared minus 11 squared. It's a little easier. 11 times 11 gives me a 2, 1. Although it doesn't look like it, this is a bear problem. It's a two-stepper. All right? We'll solve like you normally would. Try to get that B by its lonesome. Let's throw this away. It's 15.21. So subtract the 5, 15.21. Minus 15.21. Be gone. So I'm left with B squared is equal to 120. Emmett, I didn't even say it. Emmett, 121 minus 15.21 gives me a 105.79. Very good. One last step. B is not by itself. There's that square. How do you undo squares? Square root. Square root. Square root. The roof is on fire. Now, when you do this, you'll notice something. I'll tell you, the square root of 105.79 isn't going to be a nice looking number. It's not going to be nice. So, when I do this, instead of using equals, I'm going to use approximate because it tells me to round to the nearest tenth. How far is a tenth? How many decimal places is a tenth? 2, 7, 1. There's not a 1. I'll tell you that. Tenth is the first decimal spot. Tenths, 100, 1,000, 10,000, 100,000, all that stuff. So it is just one decimal place. And since I'm rounding, I keep doing that, it's going to be approximate. It's going to be double squiggles there. So when I do 105.79, what is my approximate answer? 10.3. It was 2 something, right? 10.28. Is that what it is? So it's approximately that. And there's my answer. So B is approximately 10.3, rounded to the nearest 10, one decimal place.
Mr. Carr, for time, do you want to skip 4?
Yeah, let's skip 4. Yep. Go there. Same exact way, set it up here, the next one here. So let's check to see if something is Pythagorean triple here. So, we have these things with Pythagorean triples, they help you save time. Because if I recognize this, I don't have to do work. If I know that it satisfies one of these, I know 2 sides, I automatically know the third side. It's kind of a preview. Once you memorize, you get better with these. So how in order to have a Pythagorean triple or a P-trig, they have to follow these rules. Well, first it has to be a triangle. That means that 2 sides of the triangle must be greater. So I pick the 2 small sides, add them together, they have to be bigger than that third side. The next thing for a right triangle, well, it has to work with the Pythagorean triple. Both sides of the equation have to be, or Pythagorean theorem, both sides have to be balanced out. So A squared plus B squared equals C squared, they have to be the same. And the last one, very important here, they have to be whole numbers. So you gotta have all three of these in order to be a Pythagorean triple. And again, this is a time saver, because if you recognize this, I don't have to do any work. I can just put down my answer right now because I know it's always going to be true. So let's determine if these sides are Pythagorean triples. These are their whole numbers, all that stuff right there. Well, first, is this a triangle? Take the two small sides, add them together. What are the two small sides? 6 and 8. What's 6 plus 8? No, 14. Is 14 bigger than 9? Yes, then we have a triangle. We satisfy the first one. Is it a right triangle? All right. All I have to do is put it in the Pythagorean theorem to see if it works. One thing has to be true. You have to know this. There's one side that has to be the same no matter what you do, how you set up. A and B can be whatever they want, but what does C have to be? Has to be across from the right angle, but it also has to be the largest side. It always, C value is always the largest one. So which one do you think is going to be your C value here? 9. The other ones, they can be A and B, doesn't matter. I'm just going to go in order since I have that. So I'm going to say 6 squared plus 8 squared is equal to 9 squared. And let's see if we have a Pythagorean triple here. 6 squared gives me a, yeah, you guys all done these. The numbers will repeat themselves a lot. 8 squared is a, and 9 squared is a. All right, 36 and 64. 100. Does 100 equal 81? No. So guess what? They do not equal one another. So this is not a, I call these P-trips, so I don't write Pythagorean triple all the time. Not a P-trip. So basically this is a triangle, but it's not a right triangle. That just satisfies that. All right. So not a P-trip. The number's not the same. That means there's no right angle in that triangle. Let's look at the next one. A 5, 12, 13. Which side's going to be my C value? 13. 13 is. A lot of times they go in numerical order. They don't always, though, so make sure you're paying attention to that. So 5 squared plus 12 squared equals 13 squared. 5 squared is a 25. 12 squared is a 155. 13 squared is a 169. Okay. 25 and 144. 169 equal 1. So are both sides, are they balanced? Are they equal? Yes. So this is a P-trip. Yes. A P-trip. Pythagorean triple. Why is that important? Because if you're given a problem and you know it's a right triangle, and you know two sides are 12 and 13, no work needed, you know the last side's 5. Or if I know one side's 5, one side's 12, then I know the third side's 13. Or vice versa, if I'm 5 and 13, the other side's 12. It's just a way of knowing what it is without doing any work, because it's always going to be a Pythagorean triple. So it's just a time saver. All right, the last one here. Okay? What am I going to do with this one? Could this be a Pythagorean triple? Shaking his head. I haven't tried anything. How do you know? They have to be a whole number. As soon as you see decimals, I automatically know not a P-trip. And again, I promise you guys, my handwriting is not that squiggly. Somewhere in the middle of the board is little squiggles there. So it's not a P-trip. Questions on that one? All right, let's start with this one. Given that I have two sides, find a number that will create a Pythagorean triple. All right. Well, I'm trying to find a third side. Again, if you start memorizing your P-trips, you just look at it and say, I automatically know what the next side's going to be. But you're not there yet, so we got to figure it out. Well, here's what happens. There's one guarantee that has, it's covered, but there's one thing I need to know for sure in the Pythagorean triple, and it's that C value. What does C always have to be? See, relative to the size, what does the C value always have to be? Cross the line, it's the largest side. So we got to figure out, well, are we looking for the C value, or are we looking for one of the A's or B's? I don't know. Maybe we don't have both. Maybe we don't have a right triangle. But since we're saying Pythagorean triple, we probably are. So here's what I'm going to do first. I'm going to say that this is A and B, and I'm looking for C. I want to see if this is balanced. So So I'm going to plug it into the formula to find the C value, to see if that's it. Maybe it is, maybe it's not. Let's look. So A squared, so I'm going to say 6 squared plus 10 squared is equal to C squared. If I get a nice number, perfect square, then I'm golden. Because again, it has to be a whole number. So let's go ahead and solve. 6 squared is a 36. The numbers repeat themselves. 10 squared is a 100 equals C squared. 36 and 10 gives me a, oh, what was it? 36 and 100, excuse me, is a 136. C squared. How do I solve? I do square root. Square root. Is 136 a perfect square? 136 perfect square? Again, check yourself. Do square root of 136. You guys are shaking your head no. What does that equal? 11 point what? Yeah, 11.6 or 7, how do you want to round it up? I'm okay with that. But we know it's a decimal here, so that's not going to work. So C can't be the value we're looking for. We're going to try it in. We already said that C has to be the largest side. Well, what side between 6 and 10 is the largest one? Which one's bigger, 6 or 10? 10 is. So let's try that being the C and see if our missing number is either going to be an A or a B. So I'll keep 6 there. So 6 squared plus T squared is equal to 10 squared. I'm just checking. Is this my C or my B? That's all I'm checking. And we go ahead and solve. The numbers remain the same. So 36 plus B squared is equal to a hundo. Back to our bare problem. Some of you guys are solving already. Good for you. Subtractify 36. Subtractify 36. He gone. B squared is equal to 64. Some of you guys are saying, uh-oh, and what's going to happen next? Square root, the roof is on fire. Is 64 a perfect square? Square root of 64 is 8. So guess what? That other number is 8. So I know the numbers would be a 6, an 8, and a 10. What are your thoughts on that one for a second? Yeah, that's a check to find that missing side that will make the Pythagorean triple. Check to see if it's the C value. If it's not, check to see if it's either an A or a B. If it's neither, then it's not a right triangle. So we found B is my missing value. Question on that? Now this one. Sit down, stay calm, and focus yourself. You guys are going to, your mind will melt. I'll tell you, for 5 minutes, your mind's going to be melting. Write it down and understand. We're just proving why this works. So just understand, your mind's going to be blown for a second. But then it's going to dial back in and say, oh, okay, I get it now.
It will be okay. And we're not going to stick this problem on the test. We're not, but it's just something it's important to know where the Pythagorean came from. And there's different ways of deriving where it came from, or proving where it came from. We're going to use similarity. So exactly what we did in the last unit. Just hang tight. You'll be okay. Follow along with what we're doing. Make sure you get it down. You're gonna just fine.
Okay? Little triangle and big triangle.
You know there's a big right triangle here. Triangle ACB. Right? Well, that big triangle is similar to this little triangle that was drawn inside of it. We drew in an altitude. There we go. That triangle, those two triangles are similar by angle. They both have a right angle, and they share angle X. By angle, those triangles are similar. Okay? Well, let's say triangle ACB is similar to triangle AB. I know the triangles are similar. Okay? Well, if triangles are similar, then we know their sides are what? Proportional. So we can set up a proportion involving those sides. Okay? So if we look, how we're going to set this up? Here we have in the big triangle, we have the hypotenuse. Okay? The hypotenuse is AB. Okay? Now the hypotenuse in the big leg of the big, right? The leg of the big, which is this guy right here, and say, mess this up, what? Sorry, I pop AC, sorry. Leg of the big, which is AC, over the leg of the little, which is AB. Okay? We just set up the proportion of those sides. Hypotenuse of the big over the hypotenuse of the little is equal to the leg of the big over the leg of the little. That's exactly what we did here. Okay? Then, fill in those values. What little letters representing AB in that diagram? AB, all the way across. What letter? C. I'm going to place C there. What little letters representing AC? B. And again, we said AC was B. And what little letters representing AD? X. Okay? If we're solving a proportion, how do we solve them? Cross multiply. There's nothing really to solve, but we're going to get rid of those fractions by cross multiplying. So C times X is what? And B times B is B squared. That part right there. Okay. We're going to do the same thing, same exact thing, with this other little triangle. This guy right here. They are also similar because, again, they both have a right angle. This angle is a right angle. And they both share angle B. So we know they're similar. Okay. We're going to do the same thing. We're going to say the hypotenuse of the big. So here's the big triangle. We said the hypotenuse of the big was AB over the hypotenuse of the little. What is the hypotenuse of the little? Cross from the 90. It is what? BC. Hypotenuse of the big over the hypotenuse of the little. Over the leg of the big, but you have to be careful, the leg of the big also has to be in this triangle. Got to be connected. So we're going to say the leg of the big, the other leg is BC, and the leg of the little is BD. Okay? So hypotenuse of the big over the hypotenuse of the little is equal to the leg of the big over the leg of the little. So we have to use this leg, so it has to be also in this triangle, other little triangle. Fill in those little letters that are representing those pieces. Okay? What little letter represents AB? What did we say before? C? Good. What little letter represents BC? What little we said A represents BC. Which little letter represents BD? Y. And again, what are we going to do to get rid of these fractions? Cross multiply. So C times Y is just CY. And A times A is A squared. There's that other little piece. Well, if we look back at the Pythagorean theorem, the front of your notes, what do we do with A squared and B squared? We add them. Well, let's go ahead and do that here. We're going to say A squared plus B squared is equal to, well, what also represented A squared? CY, and what represented B squared? CX. Well, if we added these two together, we can also add these two pieces together. They're the same thing. Alright? This is where kind of trickier part comes in. You have to think back to algebra 1. We can reverse the distributive properties. If you notice how these both have C's, we can take out a C, and we're left with Y plus X. Because if we were to take C and distribute it, C times Y is CY, C times X is CX, we just reverse that. Well, again, if we look back at our diagram, we add Y and X together, it gives us this whole segment. What did we say that whole part represented? C. So this part is like saying Well, what is C times C? C squared. A squared plus B squared equals C squared. And we are done. Oh, your grades can stop melting.
Stop melting. All we did was show you why it works. So guess what? Now you just understand it to be a true statement and always use a squared plus b squared equals c squared. Just like we always do in this, we do a proof of why something works. Now you know it works. Use this tool.
So it's just like when you're given a theorem. Well, why does that theorem work? Here's the proof. You don't really ever see the proof. You see it again maybe sometimes, but you know where a squared plus b squared plus c squared came from. You are donezo with knowing this part. Just know that a squared plus b squared equals c squared. Okay? Questions?
Alrighty.
Nope. That's the last part.
Nope, last part. Boom! Blank thing. Snowman and snowstorm. Drew that myself. But the last part, probably one of the most important one, is the time saver. Those last three at the bottom. It says summing things up. List most common Pythagorean triples. I will list them for you in a variation of these ones. So if you're going to know three of them, learn these three, because there's questions all the time that will say, list three Pythagorean triples. The first ones I'm telling you are the smallest ones. These are the ones that are most common, and basically all P-trips are based off these three for the most part. There's more they go on forever. There's formulas to figure out what they are, like we did a second ago, but let's not do this. The first one, and the smallest of the P-trips, and the only one that is consecutive in a row, meaning all numbers are sequential, they go in a row. This is it. The 3, 4, 5 triangle. This is the smallest right triangle you can have. A 3, 4, 5. Again, why is this important? Because if I have a triangle and I have a picture, I'm looking at a picture, and I see that I know it's a right triangle, 2 of the sides are 3 and 4, automatically, I don't do any work, I know the other side's 5. Save myself time doing the Pythagorean theorem, I know that side's going to be 5. Or vice versa, then I have 3 and 4, or 3 and 5, I know that other side's 4, off the bat without doing any work. And I'll show you a variation we do with these as well. Number 2, another one, and you actually saw this one already today. It was our first one that you guys discovered. Another one, the second most common you will see, and the second largest, is the 5, 12, 13. Or I should say the second smallest. That is another triangle there, the 5, 12, 13. You will see that. The last one, again, is you don't see very often. These two are the ones that dominate the majority of the problems. But the other one you will see, the next of the smallest, is an 8, 15, 17. That's the next one you will see. Now, here's a thing that's really cool about this. Because these two are basically the foundation for the vast majority of P-trips out there, Pythagorean triples out there. Why? Because I can create new ones just by multiplying them all by the same ratio. Because I can do like scale factor with these. What I mean by that is this. I can take a number and make new ones. So if I have a question that says, name 3 Pythagorean triples, you can have these 3 memorized, or you just memorize this one, and I increase each of those numbers by the same amount. And this is where the one problem that we did in finding the other side, I knew without doing any work because of this. So let's multiply these numbers all by 2, and let's see what happens. Because you will create, since we're all increased by the same amount, it will continue to be a Pythagorean triple. So what is 3 times 2? What is 4 times 2? Don't square it. 8. And 5 times 2 is 10. So I automatically knew on that problem, my answer is going to be 8, because I knew there was a 6 and a 10. That means the middle side had to be 8. That's how you're going to do it. You can multiply by any number. I can take my other one, let's multiply by 3. 9, 12, 15. There's another one. Another Pythagorean triple I just found. Multiply them all by 100. 300, 400, 500. It's still a Pythagorean triple because I'm increasing it or decreasing by the same amount. Now decreasing won't work for all of these. And I can do the same for these other ones too. Multiply by 2, doesn't matter. 24 and 26. Again, that's another common one you'll see a lot. So if you can recognize these base ones, they go and they make the vast majority of math problems out there. So if I was going to learn 2, I learn those 2. If I'm going to learn 1, memorize that one. All right? Questions on that? Pass that, right?